beautiful. So this is what we have today, and as you can see, it's looking fantastic. Well, I welcome everybody tonight, and as you can see, the question we have on our screen, it's question number 12 from MIT Integration. Now the topic is natural log rule, and this question is MIT Integration BEE 12. The question says integrate 2x cubed minus 1 all over x plus x raised to the power 4 dx. So as you can see, this is the equation we have at our disposal. So how do we go about it? Looking at it very carefully, we see that if we decide to use algebraic method to divide, to do some kind of division, well, it's possible, but it's going to be very long and complicated. At the end of the day, this is time pegged. There's a certain threshold or stipulated period of time that one is supposed to finish this question with ease. All right. Now, if we look at the denominator, somebody may suggest that we can use substitution. However, when we use substitution and we differentiate x plus x to the power 4, we're going to have 1 plus 3x cubed. That hasn't got any similarity to our equation. Well, let me put all this long theory aside and let's set the ball rolling. Okay. So, as we can see, the question given to us was log integral of 2s cubed the integral of 2s cubed minus 1 all over x plus x raised to the power 4 dx. Wow, as I was saying, if you look at the equation, all what it comes to mind is, well, why don't we tackle this way by letting the x raised to the power x plus this raised to the power 4 to be equals to u. If we say so, then the differential of this, okay, to u will be equals to 1 plus 3x cubed all into bracket dx. And if you look at the equation, you will see that the top one, the numerator, is 2s cubed minus 1. Well, there's not a similarity. Okay, then somebody will say, okay, if that is the case, why don't we maybe divide the equation by all through by x? Okay, let's see. All through by x. So let's divide the equation. Let's divide the expression all by x. If we do that, okay, we are going to have the integral 2s squared minus 1 over x all divided by 1 plus s cubed dx. does it help us at all if we decide to also depend on the denominator? So we'll let the denominator to be equals to 1 plus s cubed. You see, because we are divided through by it and we haven't changed anything at all. So what we have is a 2x squared minus 1 over x all over 1 plus s cubed. So let's see, when we differentiate again, we will see that we are going to get 3s squared dx, which is also not useful because it doesn't bear any resemblance to this equation once again. Okay, to this equation once again. Let's see, let's look at the numerator. Okay, if we use the substitution, it wouldn't be wise. Okay, so let's try something. Okay, so why not divide then through by 1 over plus divide through by s squared. Okay, and let's see. So if we say that, then our integration is going to be the s squared means 2s cubed minus 1, which is the top one, all divided by x squared. Okay, and that our numerator, which is x plus x4 all divided by s squared again, and let's see what we are going to get. Alright, when we do that, what we are going to get is 2x minus 1 over s squared all over 1 over x plus s squared, the integral of that. Well, let's see. If we decide to say, let's this time around, let u be equals to 1 over x plus s squared. Well, this maybe it can help us to break it down. So when we differentiate this, we are going to get du to be equals to minus 1 over s squared plus 2x into bracket dx. Now, when we look at this equation and compare it to what we have now, look at it. How simple can it be? So our du is equals to minus 1 over s squared plus 2x, which is exactly what we have on top of the numerator. Okay, look at it. It's on top of the numerator, this. So meaning we have been able to break the back of the camel. So what do? We make the dx the subject. Okay, so our dx from here will be equals to dx is equals to du all over minus 1 over s squared plus 2x. Okay, so this is the key. Now, by substitution, okay, we have the equation we have as we You can see, let's go up again and see how this is equation. So the equation integral 2x minus 1 over s squared all over u, because we decided to make u this to be the u, so that this one will be over u multiplied by dx. Okay, so by substitution, our integral 2x minus 1 over s squared over u, then we put the x in its place. So this is going to be du all over 1 minus s squared plus 2x. So this and that will cancel, as you can see. Okay, this and that will cancel. This and that will go. This will cancel this. So we'll be left with du over u, the integral of du over u. So now we know that when we integrate that, du over u over u over u du over u where our answer will be natural log of u plus c, but u is equals to 1 plus x, 1 over x plus, as you can see over here, plus s squared. This and that, that's the u, plus x squared. So when we put this into the equation, then our equation finally will be integral, the natural log of u, which is into bracket. Okay, then we'll put our equation 1 over x plus s squared. So the answer is natural log of 1 over x plus s squared plus c. Yeah, natural log of 1 over x plus s squared plus c. This is the final answer. Okay, now so we see that when you are doing integration, your algebraic breakdown or algebraic expression comes into place. You must be very, very attentive and look and observe fast when you are doing an exam, to be able to analyze and see which one will be quicker for you. Okay, so let's recap. So as we look through the equation, what we had was a 2s cubed minus 1, okay, dx. So we were thinking of initially to use division, long division. Okay, that was going to be something like the x plus x4, okay, and then 2s cubed minus 1, okay, and sort it out and be able to, when we split it together, then that will be able to integrate with ease. But we opted for the u substitution later on. And with the u substitution, when we decided to make u to be equal to the denominator, Initially, when we tried, we had this result: 1 plus 3x, 3x squared cubed. Didn't have any resemblance to the equation, so we put that one aside, and we decided also to divide through by x. You see, and this is what we had, and it wasn't helpful. Now later on, we decided to use x squared instead of x. So when we did that, our final result was 2, okay, 2x minus 1 over x squared divided by 1 over x plus x squared dx. Right, then, fortunately, we decide to use the denominator, the new denominator, for our u substitution. So after differentiation, we realize that our new numerator and denominator bore a certain similarity. So we decided to use that one as substitution, and lo and behold, they cancelled each other. Then we got to this point where we had the integral du over u. And we all know that when we have du over u, that is 1 over u du. When we integrate, the answer is usually and mostly natural log of u plus c. So after that, we substituted the u that we used into the equation, and our answer became natural log of 1 over x plus x squared plus c. And this question, as you know, is coming from MIT, and we're supposed to do this question quickly when we are faced with this question in the examination. Okay, anyway, thank you very much for participating. Please subscribe, and invite your friends to come along and do the same. Have a beautiful evening. Bye.